Hi friends, welcome to Curie Electronics. Today we are going to solve Space Application Center Ahmedabad, that is SAC 2018 Electronics Mechanic question paper. So please share the video with your friends. So we'll go to the first question. Okay, this exam was conducted on 18/11/2018. So 90 questions were there and the exam was 2 hour exam, not 2 hours, 1.5 hours, 11:30, 12, 1. So we'll see the questions. So if you are a ASRO or if you are into ISRO or any government exam based on diploma or ITI, this will be useful to you. Like BARC, Railway, many organizations, government organizations. These questions will be useful. So the first question, identify the symbol. This symbol is for channel diode. Answer is option D, channel diode. Now what is the symbol for varactor diode? Varactor diode symbol is like this. This is a varactor diode symbol. Varactor diode symbol. Varactor diode symbol. What is the symbol for NOT gate? NOT gate is like this. NOT gate. What about Zener diode? Zener diode symbol is like this. This is Zener diode symbol. This is the NOT gate symbol. This is the varactor diode. Varactor diode. So the answer is option D, channel diode. Question number 2. Second question. Under small forward bias voltages in tunnel diode, the forward resistance is. Answer is option C, very small. Under small forward bias voltages in tunnel diode, the forward resistance is very small. The tunnel diode, we'll see how it is. We'll just see the tunnel diode characteristics. Oh, sorry. This tunnel diode, it is a negative. This tunnel diode has got negative temperature coefficient. Negative temperature coefficient. So this is the forward voltage. This is the forward voltage applied to the diode, and this is the forward current. Now, if we draw the graph, we will get a graph like this. First, it will increase like a normal diode. Then here, like this, we will get one kind of graph like this. See, this is the small voltage drop. Up to here, we are applying a small forward bias. So this very small, this is the region, and this maximum, when it reaches the maximum current, this is called the peak point in the forward biased characteristics. And if you see from here to here, it exhibits negative resistance. That is negative resistance. And from the last part of the curve, this part is just like a conventional diode. Conventional diode. The last part of the curve is like a conventional diode. That means it is just like a normal diode starts, then it goes, the current reaches a peak value. That point is peak point. V peak, it is known as peak point. This point is known as peak point. Vp equal to peak point. And then it goes to this point here, this is the value point, v point. This is the v point, this is the value point. I'll draw with another pen. This is the valley point, valley point. This point is the valley point. So this is the this just you should know the curve how it looks like, so that you can answer the questions easily. So this is the next question. Question number 3. Question number 3. Calculate the inductance of the following circuit. Inductance, when you simplification, is similar to resistance. Now these two resistors, L is 60, L3 is in parallel with what? L4. Now for this, L equivalent equal to L3 multiplied by L4 divided by L3 plus L4. Now what is the value? If you, I'll write it here itself. What is the value of L4? L4 equal to 60 multiplied by 60 upon 120 sum of L3 and, so 360 upon 12. What will get? What is 360 upon 12? Which equals 360 upon 12 equals what? 3 times 30. We got 30 millihenry. Units are there in millihenry. Milli means what? Milli equal to 10 to the power minus 3. Milli equal to 10 to the power minus 3. Now this inductor circuit becomes, how it becomes? It becomes like this. First inductor, then one more equivalent inductor. Now we have to see what is the L total from here. Okay, so what is the L1 value? 30 millihenry. What is the L2 value? L2 also 30 millihenry. What is the equivalent what we got? That is 30 millihenry. So all the values are 30 millihenry. When these, so LT equal to what? LT equal to 30 plus 30 plus 30, which equal to 90 millihenry. So the answer is option C. 90, no, sorry, not option C. 90 millihenry we got. That is option A. Option A is the answer. Answer is option A, 90 millihenry. Question number 4. A DC source is connected to a series combination of 10 ohm resistor and a 10 microfarad capacitor. What will be the current through the circuit under steady state? So one resistor is there. When one capacitor is connected, what is supplied? It is equal to 20 volt. 20 volt is the source. That is 10 ohm. 10 ohm resistor is a series circuit. And this value of the capacitor is 10 microfarad. Now what happens under steady state? Under steady state, this current, if you represent by I equal to 0. Why? Because the capacitor is completely charged. See, the curve looks like this. This is the I versus, if you draw circuit current versus time, initially the capacitor draws maximum current. That is, at time t equal to 0, it draws maximum current. Then it becomes like this. It becomes straight. And ideally it will touch the 0 point. So after occurring steady state, it draws no current. So the answer is option D, 0 amps. Question number 5. If three resistors of 1.5 kilo ohm, 200 ohm and 3300 ohm are in series with 25 volt source, what is the total current? Total circuit current. That means we have three resistors connected in series. It is 1.5 kilo ohm. Then what is there? 200 ohm. So that also I will make it zero point 0.2 kilo ohm. Another one is 3300. So I will make it 3.3 kilo ohm. These three resistors are connected in series with a voltage source, that is 25 volt is the voltage source. Okay, so this is 25 volt. What is the total circuit current? So in a series circuit, current is same. This I we have to find out. What is I? I equal to V by R. What's the voltage? 25. If I add these resistors, what happens? 1.5 plus 1.7. No, 3.3 plus 2.2. 3.5. 4, 5. We'll get 5. Correct. 5 we got. Correct. That is 3.3 plus zero point 0.2 equal to 3.5. 3.5 plus 1.5 equal to 5. So 25 divided by 5. We'll get 5. What's the unit? 5 milliamps. 5 milliamps. Whenever you solve a resistor network, voltage you take it as volts always. Current in milliamps. And resistance in kilo ohms, so that you need not to worry about the units. So always try to follow this convention, this method, so it will be easy. You need not to worry about the units. So the answer is option C, 5 milliamps. We'll go to the sixth question. Question number 6. Which one of the following is not true? 1 milli ohm equal to 10 to the power 3 ohm. This is true. Correct. 1 micro ohm equal to 1 micro ohm is equal to what? It is equal to 10 to the power minus 6 ohm. So this is not correct. This is the answer. What is 1 mega? 1 mega equal to 10 to the power 6. Then we what is 10 to the power minus 9 ohm? How we will call it? This is 1 nano ohms. Okay. What is 10 to the power minus 12? That is pico. So 10 to the power minus 12 ohms, 12 equal to, how do we say, that is 1 pico ohms. So we'll go to the next question. Question number 7. In AM receiver, the oscillator frequency is always in AM receiver, the oscillator frequency is always greater, always higher than the signal frequency. Always higher than the signal frequency. F oscillator frequency will be F signal frequency plus intermediate frequency. Intermediate frequency. So oscillator frequency is always higher than the signal frequency. Question number 8. Jolly, jolly. Okay, question number 8. Electronic components which are made of a semiconductor material are often called. Generally, they may be called, all these are solid state devices. If it was a vacuum tube, it is made up of glass. It is not a glass and metals. It is not a solid state. So the answer is electronic components which are made of semiconductor materials are often called solid state devices. That's why under solid state devices we study transistor, MOSFET, all those things. What is the intrinsic? Intrinsic is a pure semiconductor. Pure semiconductor. Pure semiconductor is the intrinsic semiconductor. Intrinsic semiconductor. Okay. To break the potential barrier, What is the potential barrier voltage? Barrier voltage of voltage of germanium, that is Je, that is 0.3 volt. Similarly, what is the potential barrier voltage of silicon? That is 0.7 volt. Question number 9. Question number 9. This 120 to the base 10, 120 to the base 10, we have to convert it into what is to the base 2. So what you will do? We will just divide it. Correct. This is a method we follow. 120 divided by 2, 60. Remainder 0. Again, divide by 2, 30. Remainder 0. Again, divide by 2, 15. Remainder 0. Again, divide by 2. 7 times. Remainder 1. Again, divide by 2. 3 times. Remainder 1. Remainder 1. Again, divided by 2. 1 time. Remainder 1. Then we will write it from bottom to top. Bottom to top. Now, okay, now how do you write? That is which equal 120 to the base 10 equals from bottom. From bottom we will start. That is 1 1 4 ones 0 to the base 2. So the answer is 4 ones are there. Yeah, 1 1 1. Answer is option A. Option A is the answer. So we'll go to the next question. Question number 10. A square wave front will be seen on, which is the instrument where we can see the waveforms. That is absolutely oscilloscope. Previous olden days we used to have cathode ray CRT oscilloscope, cathode ray to oscilloscope. Nowadays we have digital storage oscilloscope, that is DSO. Question number 11. So all of you study well, have fun, all are required. Everything is required in life. Okay. Question number 11. A voltage source that converts chemical energy to electrical energy is called. It's a battery. Answer is battery. We know dry cell. Normally we use that is. So the solar cell. Okay. The answer is battery. Chemical to, that is chemical energy to electrical energy. The solar cell, what it gives out, AC or DC? It gives out DC. I think what was the voltage? I don't remember now. I think it's somewhat to 10 volt, near to 10 volt. Okay, it's a DC. It gives out DC voltage. Question number 12. A voltmeter is used to measure current. A voltmeter. We know voltmeter is used to measure voltage, but how we use it? In parallel with the circuit. That means if you want to measure the voltage across a resistor using the voltmeter, what you do? We will connect the voltmeter here across parallel to the component. So the answer is option C, in parallel with the circuit. Question number 13. A 100 micrometer movement with an internal resistance of 800 ohm is used in a 0 to 100 milliamps ammeter. Find the value of required shunt resistance. Okay. Now using a shunt resistance, we can increase the rating of a ammeter. Now I'll show you how to do it. Now we have a voltage source. We have a load also. Now here we are using the ammeter. Ammeter will be used in series. Okay. This ammeter will have what it will have. This ammeter will have one resistance, that is Rm. This ammeter will have one resistance. And If you want to increase the range of this ammeter, what we do, we can connect a shunt. We can connect a shunt here, shunt resistor. We will connect ISH. We will connect a not RSH, shunt resistor. We will connect. Sorry, I'll write once more. So I hope these videos are useful to you. So please make use of it. RSH, this is a shunt resistance. Now, one thing if you observe, the voltage between these 2 points will be across these two RM and meter resistance and the shunt resistance are in parallel. So voltage across them is same. So we can write like this. What we can write? We can write as Rm multiplied by Im. That is the current through the meter and voltage through equal to RSH multiplied by ISH. Understood? Because across these two components, this meter will have a resistance and the shunt resistance, both are in parallel, so their voltage has to be same. Now, what is the RM value he has given? Meter resistance he has given us 800 ohms multiplied by what is IM, 100 microamps, that is 10 to the power minus 6, each equal to what is the value of RSH? RSH we have to find shunt resistance value. What is ISH? 100 milliamps, 0 to 100 milliamps. So maximum is 100 milliamps, 10 to the power minus 3. Now, what we can do? We will simplify this. Okay, 100 cancels. Left and right of the equation, 100 cancels. If I multiply, okay, now 800 into 10 to the power minus 6. This 10 to the power minus 3 cancels with here. Then what will be left? 800 multiplied by 10 to the power minus 3 will be left in the RSH. So R shunt resistance value equal to 800, which equal to what? R shunt resistance value equal to, if you multiply 10 to the power minus 3 means what? 800 divided by 1000. Correct. This 10 to the power minus 3 equal to what? 1 divided by 1000. So cancels 0.8 ohm we will get. So 0.8 ohm shunt resistance, we have to use this with the original meter, then we can measure up to 100 milliamps. Question number 14. Which of the following is known as equivalence logic? Equivalence logic. Which of the gate is known as equivalence logic gate? That is XNOR gate. Why? If you have a XNOR gate is like this. Okay, it's a XOR gate. We have two inputs A, B and B. Y is the output. Whenever inputs are same, 0, 0, 0, 1, 1, 0, 1, 1. Whenever inputs are same, we will get output as high. That is why this XNOR gate is known as equivalence gate. See, equivalence. You can see the equivalence. Here also we can see the equivalence. So the answer is option B, XNOR gate. Question number 15. Identify the symbol below. Power MOSFET, LDR, IGBT, PHEMT. IGBT means what? Insulated gate bipolar transistor. Insulated gate bipolar transistor. The answer is IGBT. How I understood? There is no direct, in the symbol there is no direct connection. There is isolation is there, and the remaining part is a transistor. So it is a IGBT. Power, what is LDR? LDR, how it will be? LDR, light dependent resistor. LDR, this is the symbol for LDR. On a resistor, light will be falling it. PHEMT, I don't know. Power MOSFET. MOSFET, how it will be? MOSFET will be like this. It can be Something similar like this will be simple. MOSFET. MOSFET here one arrow will be there. From that arrow we can identify whether it is P channel or N channel. This is what this is arrow is going out. If arrow goes out, it is P channel MOSFET. P channel. P channel MOSFET. If arrow comes in, it is N channel MOSFET. Question number 16. A Darlington pair has dash input impedance. What input? Very low, very low. How a Darlington, what is a Darlington pair looks like? A Darlington pair looks like this. A Darlington pair, collectors are connected together. Collectors are connected together, and we will take the output from here. Output. This will be the input. So it will have a high current gain. The current gain is given by high current gain is very high for that is beta 1 multiplied by beta 2 is approximately the current gain. Current gain. Current gain. For a Darlington, it will have very high output impedance, very high input impedance, and oh sorry, the answer is wrong. Okay, let me change it. Let me change it. Because we should have very high output, very high input impedance. A Darlington pair has a very high input impedance and a very low output impedance. Output impedance. Output impedance. Impedance is represented by using the letter Z. Okay, so take care of it. Why? See, these Darlington and all you will use as a buffers. All buffers should have output impedance low and input impedance high. Why input impedance high? Because from the other previous circuit, I should draw very low current. And the output, most of the loads will have output side. If you see, I will so that you will remember. I will tell you. If you have a speaker, if you have a speaker, this is a speaker we have. This speaker will have almost 8 ohm or 4 ohm. So to power the maximum transfer, power transfer, we need what we need. We need a low output impedance. Low output. If 8 ohm is the output here, then it will matches with the speaker. Not there. Here. This will matches with the speaker. So it should have low, very low value. Okay, we'll go to the next question. Question number 17. Okay. Power dissipated in an ideal diode is. Okay, tell me what is the power dissipated, guys? An ideal diode, what is diode symbol? Diode. Diode is like that. The ideal diode, when it is forward biased, what happens? Forward bias, what happens? It will act like a switch. Short circuit switch. Act like a short circuit switch. So what is the voltage drop across ideal switch? It is 0. So power dissipation also 0. Question number 18. Which of the following components are active components? Op amp is an active component. BJT is an active component. But thermionic valve is not an active thermionic triode. This is valve. Okay. The thermionic triode means thermionic valve, thermionic triode, diode, anything comes. It is a valve. Okay. Thermionic diode, but diode is not a active device. But thermionic triode is a active device. Or pentode, tetrode, all are active devices. So the answer is option B. Now, okay. Capacitor is not an active device, it's a passive device. Passive, what are the passive devices? Passive, that is inductor. Inductor is passive, capacitor is passive, resistor also passive. Mainly these voltage sources, current sources, a transistor, MOSFET, all those stuff are active devices. Now, moisture content in the soil dash the earth soil resistance. It will decrease the soil resistance. Why? When you make a earth pit, what you do? You put some water, copper, this carbon things, all those stuff. They to decrease the soil resistance. So if it's a dry, if some see nowadays the kids will make some sensor project. When the moisture is there in the soil, it can detect. Mainly, it will decrease the soil resistance. Question number 20. In the cable, the location of fault usually found out by comparing the capacitance of insulated conductors. The answer is option C. Capacitances of insulated conductors. Capacitors of insulated conductors. Vertical deflection coils produce the vertical motion in TV sets. The structure which has the combination of two sets of coil for which the purpose is called the deflection yoke. That is called yoke. Okay, deflection yoke. On olden days TVs, we could see some two coils mounted on the neck of the CRT. That is the deflection yoke. Deflection yoke. So we'll go to the next question. Question number 22nd. The ratio of output signal to noise ratio output divided by signal to noise ratio input is known as figure of merit. Figure of merit. It's known as figure of merit. Answer is option C, figure of merit. Question number 23. Which part of an atom has no electrical charge? That is neutron. Neutron has no electrical charge. What is the charge of electron? It is negative 1.6 to 10 to the power minus 90 coulombs. Proton, what is the proton charge? Positive 1.6 into 10 to the power minus 90 coulombs. What is the mass of electron? Mass of electron that is 9.1 into 10 to the power minus 31 kg. What is the mass of proton? Mass of proton similar to mass of neutron, which is equal to 1850 times mass of electron. So we'll go to the next question. Question number 24. In a synchronous counter, all flip-flops change the state. If synchronous means together, always together, or parallel. Okay, so the answer is option C. But in the ripple counter, it's not like that. A ripple counter, delay will get added by each stage. So for synchronous counter, parallelly, it will change the states. Question number 25. The symbol Xe represents what? Capacity. Answer is option C, capacitive reactance. Conductance, what will represent conductance? That is G. Capacitive reactance, inductive reactance XL, resistance R. Question number 26. Decibel is the measure of option. Answer is option A, power level. The gain in dB, gain AV in dB. AV is the gain in dB is given by 20 log 10 of P out by P in. So this is used to show the power level. Question number 27. Which one of the following is used for the measurement of dielectric loss of capacitance? Dielectric loss. Okay. These bridges you should know. Inductance. To measure the inductance, we can use the following bridges. Maxwell bridge. This Hay bridge and Anderson bridge is modified form of Hay bridge also we can use it. And Maxwell Anderson bridge. Anderson. Anderson. Maxwell bridge. You always remember Glenn Maxwell because of Glenn Maxwell. Anderson also an English test bowler, cricket bowler is there. Bowler is there. His name is Anderson. So James Anderson. Okay. So Maxwell, Anderson, and Hay. Hay are the inductance measurement bridges. But this sharing bridge is used to measure capacitance as well as dielectric loss or loss factor. We can say loss factor, dielectric loss or loss factor. And so it is used to make the insulation measurement of cables, measurement of cables. It is used to make the insulation measurement cables also. Okay, shearing bridge is mainly used to measure the capacitance and the dielectric loss of capacitance, and it is used to measure some cables also to find the insulation. Question number 28. Question number 28. If a radio station is broadcasting at 98.3 megahertz FM radio, कैसा है भाई लोग? अच्छा है who? Okay, if a radio station is broadcasting at 98.3 megahertz, then the wavelength is approximately. So frequency is given as 98.3 megahertz. Now all of us know FM range. What is the FM range? That is from 88 megahertz to 108 megahertz. 108 megahertz. 108, okay. 108 megahertz. And okay, now what is the velocity? Velocity is given by f lambda. What is the velocity of light or any electric EM wave? 3 into 10 to the power 8 meter. 8 meter, okay. Frequency is given as 98.3 megahertz. So what I can write? 98.3 multiplied by 10 to the power 6 megahertz. Lambda we have to find out. Okay, this 10 to the power 6 and 10 to the power 6, if I cancel here, what I'll be left? I'll be left with 2. I'll be left with 2. So it will be 3 into 10 to the power 2 equals 98.3 multiplied by lambda. Approximately only he is asking. So I will round off this to, this will become 300. This I'll round it off to 100 multiplied by lambda. So lambda equal to what? 300 divided by 100. So it is 3. What is the unit? 3 meter. From where this meter has come? The velocity of light. What is the velocity of light? 3 into 10 to the power 8 meter per second. From here we got the meter. We not do any conversion because we have used the meter per second. Question number 29. Question number 29. What is LDR? What is LDR? LDR is a light dependent resistor. Answer is option B. So I showed you light, there will be a resistor. When light falls on it, the resistance decreases. That's what LDR. Okay, all of you please share the video with your friends. You could get the question paper also. And see the second part. This is the first part. We will solve the second part in the next part. That is up to 30 questions. We'll solve it. So there is one more question we have to do. Okay. This 90 questions are there. So I have to make 3 parts. This is a part 1. So we'll solve the today's last question. What is today's last question? Question number 30. Dash is used for critical loads where temporary power failure can cause a great deal of inconvenience. Answer is option B. UPS. UPS means what? interrupted power supply, power supply, uninterrupted power supply. That is what UPS. Okay, so what happens in hospitals? If you remember hospitals record this must because when then some surgery goes, when surgery is going on, if the power goes, anyway, disaster, the person could die because of the power failure. In such a critical things, we need UPS, uninterrupted power supply. What is SMPS? SMPS, that is switch mode power supply. Switch mode power supply. Switch mode power supply. To make the power supply weightless and compact and more efficient power conversion, we use SMPS. Then one more is there RCCB. What is this RCCB? Residual circuit current breaker. Circuit current breaker. This works something like if current is flowing through a human body, it disconnects the circuit. That's what residual circuit breaker. Residual RCCB. I think it's a residual circuit breaker. Once I have circuit current breaker. I think that is the full form. Please confirm it once. Okay. So guys, we have completed the first part. 30 questions we have completed. So try to make use of this thing, whatever you have to get it. Okay. So please share the video with your friends and thanks for watching. Thank you.